The speed of an AC motor is determined by the number of poles that form the stator and the frequency of the AC voltage coming into the motor. The operating speed, called synchronous speed, is equal to the frequency of the voltage times a constant of 120 divided by the number of poles of the motor. The result of this synchronous speed is given in RPMs. So, for a 60 Hz frequency, a two-pole motor will operate at 3600 RPMs, a four-pole at 1800 RPMs, and so on. This formula indicates that the only parameters that can be changed in order to vary the synchronous speed of the motor are the frequency of the voltage or the number of poles in the stator field. This is very much unlike the case of a DC motor, where a voltage variation to the armature or field would change the speed. In fact, if the voltage to a motor is not within 10% of the rated nameplate voltage, severe damage can occur due to overheating. This happens because the torque of an induction motor varies with the square of the applied voltage. So, if a motor is running at, let's say, 80% of its rated voltage, the torque will be 64% of that at the rated voltage. Induction motors run below the synchronous speed because of losses in the motor. These losses occur because the rotor lags the stator's rotating magnetic field, therefore rotating at a slower speed. This reduction is called slip and is represented as a percentage of the synchronous speed. In fact, slip is necessary for an induction motor to operate and provide torque. Most motors run at between 2 to 10% slip with no load. The initial current pulled by a motor when it is first started is called the locked rotor amperage, or LRA. It is so called because this is the required current that moves through the stator to start to move the rotor, which is at rest or locked at rest. As the rotor starts to move, current is induced and torque begins to build up. As the speed increases, the current required diminishes until full speed is achieved. At this point, the current required is maintained. This current is called the full load amperage, or FLA. The locked rotor current, or inrush current, at start is about 6 to 10 times that of the full load current. The rotor of an induction motor will develop full or maximum torque when the speed has reached between 70 to 80% of synchronous speed.